share my screen with you. And let's do some probability. All right. So the first four problems, again, are going to be a review of what we were talking about on Friday. There's a few of you that are just starting to finally get the hang of this stuff. So I didn't want to move on just yet. So I'm reading number one. It says a basket contains 3 apples, 4 peaches, and 5 pears. And you know what, by now in this type of problem, we're always thinking, what's the total? There's 3 apples, 4 peaches, 5 pears. So that's 3 plus 4 plus 5, that's 12 pieces of fruit. All right, and we're reaching in, we're selecting some fruit, and we always want to pay attention to, are we putting it back or are we taking it out and keeping it out? And when I read this problem, it says, I randomly select and eat 3 pieces of fruit. There's nothing that says I'm putting anything back. All right, and then what's the probability? The first piece of fruit is an apple, and then the next 2 are peaches. So I'm trying to get, I want apple, peach, peach. All right, and my let me write this a little bit smaller. Again, I've got 3 apples, 4 peaches, 5 pears. So that's 12 things total. And I'm picking 3 things. So I want to get an apple first. So I start off with 3 apples out of 12 pieces of fruit. So 3 out of 12. I'm going to leave a space, times. Now I didn't put this back, so assume that I was lucky enough to get an apple. Now there's only 2 apples left and 11 pieces of fruit. All right, now I want to get a peach on my next pick. So there's still 4 peaches left, but now there are only 11 pieces of fruit left. Times. So now let's assume that we got the peach we were looking for. Now there's 3 peaches left and 10 pieces of fruit. I want to get 1 more peach. There are 3 peaches left out of 10 pieces of fruit. Okay, and then I included the link to that Desmos calculator again, but you're going to put it into some type of calculator and give a reduced fraction answer. 3/12 times 4/11 times 3/10. I reduce my answer. It comes out to 3 over 110. Welcome, Dio. And does anybody have any questions on this problem? Did I lose anybody? You feeling more comfortable about this? Let's start a new one then. I roll a 6-sided die 6 times. All right. So a die, you can't take the number away before you roll it again. All right. But I'm rolling a die 6 times. So I want to do something like this. A fraction times a fraction times a fraction times a fraction times a fraction. 6 times. All right. And here's what I want to get. I want to get an even number the first 3 times and an odd number the remaining 3 times. So I want even, 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 odd, odd, odd. Well, the nice thing is there's 3 evens and 3 odds. So it's 3 out of 6. I have a 3 out of 6 chance of getting an even. And then 3 out of 6 chance of getting an even the second time. And then a 3 out of 6 chance of getting an even the third time. I've got a 3 out of 6 chance of getting an odd on my 4th time. A 3 out of 6 chance of getting an odd again. and a 3 out of 6 chance of getting an odd again. And all those can be reduced to 1/2. It's really going to be the same as 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So I'm going to show for my work 3/6 times 3/6, or I can reduce it to 1/2. But I do want to see your formulas. 3/6, that's 6 of them, right? And that's going to reduce to 1 out of 64. Does anybody feel like they're having trouble with number 2?
Can you do it again?
So first of all, do you understand the idea that because I'm rolling something 6 times, I need 6 fractions? Are you comfortable with that idea?
Yeah.
Okay. And are you comfortable with this, what I have down here, that I want even the first 3 times? So I want even, 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 and I want odd the remaining 3 times. Odd, odd, odd. You okay with that?
Yeah.
Okay. So if you think about what's on a dice or a die, you've got 3 odds and 3 evens out of 6 possible things you can get. So I'm setting up 6 different fractions to represent each time I'm rolling the dice. And if I want to get an even number, I've got a 3 out of 6 chance of rolling an even number. 3 out of 6 the first time. And now I want to get an even number the second time. Well, there's still 3 even numbers, and there's still 6 things I can roll the second time. Now I want to get an even number the third time. There's still 3 even numbers, and there's still 6 numbers on the dice. Now I want to get an odd number. Well, there's 3 odd numbers, so I continue to have a 3 out of 6 chance of rolling an odd number. And I want to get an odd number the 5th time. There's still 3 odd numbers that I could get, and there's still 6 total numbers that I could roll. And same thing with the last time. Is that a little better this time? Or no?
Yeah.
Okay. All right, let's do 2 more of these, and then I'll show you the new kind of problem. All right. I flip a coin 5 times and then roll a dice once. So there's 6 things going on again. I'm going to flip a coin 5 times. 1, 2, 3, 4, 5, and then I'm going to roll a dice. And what I want is I want heads every time I flip the coin. So I want heads, 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 heads. I want to get 5 heads in a row. And then when I roll the dice, I want to get a 3. All right, so let's think about the probability of each one of these things happening. When I flip a coin, what's my probability of getting heads? When you flip a coin, what's your probability of getting a heads?
1.
1 out of?
2.
2, good. And then same thing the second time. You can't take away the heads. There's still 1 heads, and there's still 2 things you can get. 1 out of 2 chance of getting a heads the third time. 1 out of 2 chance of getting a heads the 4th time. And a 1 out of 2 chance of getting a heads the 5th time. And now I'm going to roll a dice. There's 1 3 out of 6 possible numbers I can get on the dice. Okay. So let's show this. All right. Okay. Turn this red so it's easier for you guys to see this if you're looking at it later. So I want to show my work, which is 1 out of 2 times 1 out of 2 times 1 out of 2 times 1 out of 2 Oops, I missed it. Times 1 out of 2 times 1 out of 6. And when I do all that, the final answer is going to be 1 out of 192. So it's almost never going to happen. You're going to get 5 heads in a row and then a 3. It should happen 1 out of every 192 times you try this. In other words, you should have to try this almost 200 times before you actually get what you're looking for. You comfortable with number 3 or no?
Yeah.
All right. Now let's do another one like this. All right. A bag contains 3 red marbles. I'm going to erase this last one. So 3 red, 5 blue, and 5 yellow. And that's 13 total marbles. All right, I'm going to pick 3 marbles. So I need 3 fractions. A fraction, a fraction, a fraction. And what I want red, then blue, then red. Red, blue, red. So I start off with 3 red marbles out of 13 total marbles. So I start off with a 3 out of 13 chance of getting a red. And now I have to pay attention. Am I putting the marble back or am I keeping it out? Without replacement, I'm not putting it back. So if I got the red one I was looking for the first time, now there's only 2 red marbles left out of 12 total marbles. All right, so I took care of the red. Now I want to get blue. Well, there's still 5 blue, but now there's only 12 marbles. So 5 out of 12 is my probability of getting a blue. And let's say I got what I'm looking for. Now there'd be only 4 blue left and 11 total marbles. Now I want to get another red one. So I look, well, there's only 2 red marbles left out of 11 marbles in the bag. And if I was going to keep going, I'd cross off that 2 and make it a 1. But, all right. So this is what I want to enter in. 3 out of 13 times 5 out of 12 times 2 out of 11. And again, make sure you use a calculator that can reduce these answers. 3 out of 13 times 5 out of 12 times 2 out of 11. If you have one of these, Texas Instruments graphing calculators, you can press Math Enter Enter to reduce your answer. If you happen to be lucky enough to own one of those, but it comes out to 5 over 286. How are we doing on number 4? Doing okay?
Yeah.
All right. So to illustrate the next type of problem, so these are AND problems. I want to get a red and then a blue and then a red. I want to get a heads and then a heads and then a heads and then a heads and then a 3. Now we're going to turn to some OR problems. And I'm going to do a new share here for a second. Let's say that I roll a dice and I want to get what's the probability of getting a 3 or an even number. All right, well, let's think about what kinds of numbers we can get when we roll a dice. A 1, 2, 3, 4, a 5, or a 6. So what are all the possible things I'm looking for here? I want either a 3 or an even number. 1, I don't want. Even, I want that. 3, that's okay with me. Here's an even. 5 isn't 3 and it's not even. 6. I've got a 4 out of 6 chance, which can be reduced to 2/3. Now, you'll notice with AND problems, we're always multiplying probabilities. With OR problems, we're going to add. There's 1, 3, right? So the probability of a 3 is 1 out of 6. The probability of even is 3 out of 6. So my probability of getting a 3 or an even number, I could have added these two fractions. I could have just counted them like I did up here. There's 1, 2, 3, 4 things I'm looking for. Or I can say I've got a 1 in 6 chance of getting a 3, a 3 in 6 chance of getting an even number. So that gives me a 4 out of 6 chance of getting a 3 or an even number. People feel comfortable with what I just did? Or did I go too fast? How are we doing? Olivia, are you with me on that one? Lizzie Bet, are you with me on this or no? Where's the crickets sound? Is anybody having trouble with this? All right, I'm hope that means we're doing it.
Sir, are you recording this?
I am, yes I am.
Okay.
Right. Okay, so I'm going to close this down. Let's share the desktop again. Right, let's go back to these problems. So today, these OR problems are very easy. I roll a six-sided die. The die shows a 4 or a 5. All right. What's my probability of getting a 4? 1 out of 6. OR is plus. What's my probability of getting a 5? 1 out of 6. I add these up. That's 2 out of 6. It reduces to 1 out of 3. Again, you can use the Desmos calculator. It'll give you reduced answers. All right, here's almost an identical problem. I want to get a 4 or a 6. I've got a 1 out of 6 chance of getting a 4. Or, we're going to translate that into plus. There's a 1 out of 6 chance of getting a 6. 1 out of 6 plus 1 out of 6 reduces to 1 out of 3. All right. I've got a jar with 7 balls. They are all numbered 1 to 7. So I've got a ball with a 1 on it. I've got a ball with a 2 on it. I've got a ball with a 3 on it, a 4, a 5, a 6, and a 7. All right. I reach into a jar. I randomly pick one ball, and I want to get a 4 or a 5. Well, I've got a 1 out of 7 chance of getting a 4, or I also want a 5. I've got a 1 out of 7 chance of getting a 5. 1 out of 7 plus 1 out of 7 is 2 out of 7. And that cannot be reduced. All right, last example, and I want you guys to try some of these. I've got 5 red marbles, 3 blue marbles, and 5 yellow, and that's 13 total marbles. I want to know if I just pick one marble, what's the probability I get red or blue? Well, I've got a 5 out of 13 chance of getting a red, or means I'm going to add them. I've got a 3 out of 13 chance of getting a blue. So what's my probability of getting a red or a blue? It's 5 out of 13 plus 3 out of 13, which is 8 out of 13. All right. If you're comfortable with this, you can start the homework. You'll see it on Google Classroom. You can click on these examples if you need to look at them for help. And if you'd like to stay on the line for help, I'm happy to help you out. But that's the lesson for today.